Voltage regulation. This is transformer, supply voltage V1 and terminal voltage V2. This is the switch and this is the load. When the load is not connected to the transformer, that is no load condition. When the load is connected to the transformer and load is variable from 0 to 1, that means from no load to full load variation. The voltage regulation is the change of terminal voltage V2 from load variation from no load to full load. This is the voltage regulation. That means the variation of terminal voltage V2 for the variation of load from 0 to full load condition. This is the ideal condition. It has to be 0, but in practical cases, as the load varies from 0 to 1, the terminal voltage slightly varies. This variation should be less than equal to 4%. So lower the voltage regulation, better is the equipment. The power factor and voltage regulation, these two are inversely proportional. This is the power factor line and this is the voltage regulation line. So when the power factor increases or it is very near to unity, then the voltage regulation is also very less. Better the voltage regulation, higher the power factor. The voltage regulation can be either voltage regulation up or voltage regulation down. This is voltage regulation down. This is voltage regulation up. The voltage regulation up means with reference to full load voltage. Regulation down means with reference to no load voltage. That means change of terminal voltage from no load to full load with reference to full load, that is regulation up. In case of regulation down, the change of terminal voltage from no load to full load with reference to no load voltage, that is regulation down. This is the important formula for voltage regulation. Percentage of voltage regulation I2 R02 divided by either E2 or V2. E2 means no load voltage, V2 means full load voltage. Only one term has to be taken, not both the terms, either E2 or V2. And the load power factor cos phi. This is a plus or minus I2 X02 divided by E2 into sin phi. The plus sign is for lagging loads, minus sign for leading loads. This total term I2 R02 divided by E2, this can be taken as VR. Similarly, I2 X02 divided by E2 can be taken as Vx. The simplified formula is voltage regulation equals to VR cos phi plus or minus Vx sin phi. This voltage regulation term completely depends upon no load voltage, full load voltage. These voltages are transformer terminal voltages. When transformer is not connected to load, then the terminal voltage equals to back EMF voltage E2. When the transformer is connected to load, then the terminal voltage is V2. And other terms such as load power factor and load current, transformer impedance R02, X02. So voltage regulation depends upon all these factors. Voltage regulation is calculated at specific power factor and at constant frequency. And coming to graph of the voltage regulation with reference to load power factor. Higher the load power factor, better the voltage regulation. If the above the 4% is the voltage regulation, means the voltage regulation is very poor. The condition for maximum voltage regulation, in case of lagging power factor, the condition is tan phi equals to X02 by R02. Zero voltage regulation occurs in leading power factor. Condition is tan phi equals to minus R02 by X02. So these are the important points with reference to voltage regulation.